Problem 4934. What we need to do here is just prove that cross product of A and B dot product C cross product and D equals AC BD AC BD minus AD BC. This is D and BC. So how can we prove that? Well, to prove this, we can use multiple properties here. So first of all, A and B, C and D can be rewritten as A, B, D, A, B, C, D, G, D. No, it can be written as, let's say, D, because it's a scalar product. It's like saying, you know, A, B, and C. It is essentially C, A, B. So this is the same thing here. We can use this property and say that it equals D scalar product A, B, and C. And then this is minus D, A, or sorry, C cross product A cross product B. And then C cross product A and B, which is CB A minus CA B. And then therefore AB cross product CD cross product equals minus D negative DC B A minus CA B, which equals to DCA B minus DCBA, which means that this is the scalar and this is the scalar, so we can just factor out the scalars, and this is going to be like applying associative rule of scalar multiplication. We have CA DB minus CB DA, which is essentially the same because of we're applying commutative property of inner product multiplication. And we have, what do we have? AC BD minus AD, because these are scalars. BC. That's it. That's all the proof.